Hello there. I welcome you to this presentation on refrigeration. Refrigeration is the process of creating and maintaining a low temperature inside a enclosed space lesser than that of the surrounding temperature. In other words, the process of removing heat or maintaining a substance at a cooler state is called as refrigeration. The lower temperature level in this case is the temperature inside the refrigerator, and the high temperature level is the temperature that is prevailing in the surroundings or in the atmosphere. Now let's try to understand the terminologies that are associated with the refrigeration. The first one is a refrigerating effect. This is the quantity of heat that is to be removed from a cold body or space in a given time to maintain it at a required temperature. Next is the capacity of a refrigeration unit. The capacity of a refrigeration system is expressed in terms of its cooling capacity. The standard unit for expressing the capacity of a refrigeration system is a ton of refrigeration. 1 ton of refrigeration. 1 ton of refrigeration is nothing but the quantity of heat that has to be removed from 1 meter cube of water to convert into 1 ton of ice in a time span of 24 hours at 0 degrees centigrade. Now, basically, this is derived from the latent heat of ice, which is 336 kilojoule per kilogram. So, when you express this in some units, it will be 211 kilojoule per minute. And in terms of kilowatt, this is 3.51 kilowatt. If 1 ton of refrigeration, 1 ton of cooling has to be expressed in some other units, say British thermal unit, it is 12,000 British thermal units per hour. In terms of kilocalories per hour, it is 3024 kilocalories per hour. And basically, this is a yardstick by which the refrigeration capacity is judged, and the refrigeration capacity or the cooling capacity of any cooling system is expressed in terms of tons of refrigeration. Next is coefficient of performance. This is something like the efficiency of an engine. So basically, to express the efficiency of a refrigeration system, the term coefficient of performance is used. It is a ratio of heat extracted in a given time from a particular enclosed space to the work that is input to the refrigeration system, which is nothing but electricity. So the coefficient of performance is a ratio of the refrigerating effect by the work input, which is the electricity in terms of kilowatt hour. The COP is always greater than 1. Now, when it comes to the refrigeration system, there are 3 types of refrigeration system. The first one is a vapor compression refrigeration system. Next is vapor absorption refrigeration system. The third one is a vapor adsorption refrigeration system. Of these 3, the first type, that is the vapor compression system, is more popularly used in the refrigerators and the deep freezers. We saw earlier that whenever we want to go against the nature, it has to be done by an external mechanism. In the case of water, you need the help of a pump to pump water from a lower level to an upper level. In the case of heat energy, we require a refrigeration system to pump the heat from a lower temperature level to an upper temperature level. But here is a challenge. The energy is in the invisible form. It is not a property of the system. It can only be observed when there is a change of state. It doesn't have any physical form. So to pump the energy which is in the invisible form is a huge challenge. Hence, an ingenious methodology has been invented to overcome this challenge. We know that whenever a fluid undergoes a change of phase, either from the liquid to gaseous state or from the gaseous state to liquid state, heat would be absorbed or given out from the fluid. And this heat is nothing but the latent heat of that fluid. When a gas is liquefied into a liquid, its latent heat has to be removed. Similarly, if a liquid has to be converted to a gas, its latent heat has to be supplied. So this principle is employed in the refrigeration system. So in the case of a refrigeration system, the uh, working fluid, which is called as a refrigerant, changes its phase from liquid to gas in the component called as evaporator. Hence, the latent heat of evaporation is absorbed from the surrounding space, which is nothing but the refrigerator, and the temperature gets reduced. And in the case of a condenser, the gas transforms into liquid, thereby giving out its latent heat. So here in the evaporator, the heat from the surrounding will be absorbed by the refrigerant fluid, and in the condenser, the heat that is in the refrigerant will be given to the atmosphere. So that's how the heat energy, which is in the invisible form, it is absorbed in the refrigerant and it is released from the refrigerant in the condenser. So this is how the pumping action of the heat takes place. Now let us see how the refrigeration system works. A refrigeration system basically has four major components. The first component is a compressor. The second component is a condenser. And the third component is an expansion device. And the fourth component is the evaporator. The working fluid in the case of a vapor compression refrigeration system is called as a refrigerant. And this refrigerant exists in two different phases in the circuit. In part of the circuit, the refrigerant exists in the liquid form, and the remaining part of the circuit, the refrigerant exists in the gaseous form. Now let us try to understand the working of the circuit of a vapor compression system. Let us start with the compressor. The input to the compressor is low pressure, low temperature, subcooled vapor, and during compression, the temperature and the pressure of the refrigerant will be increased. The refrigerant will be in the form of a superheated vapor. The superheated vapor now enters the condenser. In the condenser, there will be a change of phase. The hot refrigerant exchanges its heat to the relatively cold ambient temperature outside. So once when the high pressure gas is cooled, it becomes a high pressure liquid. We all know that when the pressure increases, the boiling point increases. When the pressure reduces, the boiling point reduces. In the case of a condenser, the refrigerant comes in at a very high pressure. So naturally, the boiling point of the refrigerant will be higher than that of the atmosphere. And when it is cooled in the condenser, the upon cooling, the superheated vapor immediately transforms into a high pressure liquid. So when the refrigerant comes out of the condenser, it will be a high pressure and low temperature liquid, which is in the saturated subcooled form. The refrigerant then enters the expansion device, and the expansion device that is used mostly is a capillary tube. And in the capillary tube, there will be a sudden reduction in pressure, and because of the reduction in pressure, the saturation temperature or the boiling point of the refrigerant goes much below than that of the ambient temperature, as a result of which the liquid starts boiling. When the refrigerant comes out of the capillary tube, it will be of a reduced pressure and reduced temperature. The refrigerant will be in the liquid vapor mixture form. The refrigerant now enters the evaporator. In the evaporator, the liquid boils, it absorbs the heat from the evaporated space, and the liquid transforms into vapor. When the refrigerant comes out of the evaporator, it will be a low temperature, low pressure, saturated subcooled vapor, and this vapor is once again taken to the compressor and the cycle continues. The vapor compression system is basically a thermodynamic device. Hence, it follows a certain cycle. The cycle that is employed in the case of a refrigeration system is reverse Brayton cycle, which is exactly the opposite of the Brayton cycle, which is used for an engine. And when air is used as a refrigerant medium, the cycle is called as a Bell-Coleman cycle. The cycle has four different processes. In a PV diagram, the cycle will be looking like this. The process 1 to 2 is isentropic compression, and process 2 to 3 is constant pressure heat rejection. Process 3 to 4 is isentropic expansion or throttling, and the process 4 to 1 is constant pressure heat addition. So all these four processes constitute the reverse Brayton cycle, and if the process is plotted in a TS chart, we get a cycle like this. The process 1 to 2 being a constant or adiabatic compression or an isentropic process will be represented as a straight line, straight vertical line, and process 2 to 3 is a constant pressure heat rejection, and the process 3 to 4 is isentropic expansion or throttling, and process 4 to 1 is constant pressure heat addition. Now this slide shows the choice of components available for the condenser, compressor, expansion device, and the evaporator. As far as the compressor is concerned, the most common type of compressor that is used is a reciprocating type of compressor. But for large systems and for deep freezers, there are rotary compressors called as screw compressor or scroll compressors. And in case of condenser, there are two major types. One is a tube and wire type, and another one is a tube and fin type, more like the radiator of a car. So the tube and wire type is a most commonly used type of condenser that is used in the refrigeration systems or in the refrigerators. The earlier refrigerator systems used to have this unit outside the refrigerator, at the back of the refrigerator, and the modern day refrigeration units, they have this tube and wire type condenser built into the body of the refrigerator, and we could have observed its working during the operation of a refrigeration system. When we touch the wall of a refrigerator, outside wall of the refrigerator, we could sense the heat of the wall of the refrigeration system. As far as expansion devices are concerned, the expansion devices can be in the capillary form, or it could be in the form of expansion valves. When it comes to the evaporator can be in the form of tubes which are wound around the freezer of a refrigerator, or it could be of the clinched type, as could be seen here. Basically, this is formed out of a sheet metal with some interleaving spaces in between, with some passages in between for the refrigerant to pass through. And this is the type of evaporator which could be commonly found in the household refrigerators. Now we shall see the different components. Normally, reciprocating compressors are used for the domestic refrigerators. The reason why they are chosen is because of their low cost and the simple technology. But on the contrary, they are relatively noisy in nature when compared with the rotary type of compressors. Normally, rotary compressors are chosen for very large units, for deep freezers, as well as for refrigeration system. And mostly these are all either of screw type or scroll type. Normally, these compressors are relatively expensive when we compare with the reciprocating type of compressor. And normally, it is normally these kinds of compressors could be seen in the air conditioning systems. So in the condenser, we have two types, namely the tube and fin type and the tube and wire type, which we saw just now. Sometimes a small tank called as a receiver tank is also incorporated in the system. If there is any leftover of the liquid refrigerant from the that's coming from the evaporator, this liquid would be entrained in a receiver tank. A compressor cannot handle a liquid vapor refrigerant. A compressor is meant to handle only a refrigerant in the gaseous form. So if by chance, if the refrigerant that's coming out of the evaporator is a mixture of liquid and gaseous phase, the liquid would be retained in the receiver tank. Then the expansion device, basically this is a throttling device. Throttling is basically a sudden reduction in pressure. The high pressure refrigerant is made to flow through this valve, wherein the pressure would be reduced considerably in a single step. And as far as the evaporator is concerned, the evaporator could be of the coil type or it could be of the clinch type, as we saw in the previous slide. So this animation shows how the refrigeration system is working. As you could see, the different parts of the circuit are coded with different colors. The part of the circuit which are marked in red color has a highest temperature. The highest temperature in the system could be found at the exit of the compressor, which is a hot gas. So that is why this part of the circuit has been shown in red color. And once when the refrigerant enters the condenser, it is gradually cooled and finally that transforms into a liquid. So here we could see the transformation of the refrigerant color. So the color gets converted to yellow. And the high pressure, low temperature liquid goes to the expansion valve. And here the throttling takes place and the pressure reduces, the temperature also reduces. So here the refrigerant will be in the liquid form. It will be a mix of uh, liquid and gas. And when it passes through the evaporator, it gradually transforms completely into gas. So the refrigerant, when it comes out of the evaporator, will be completely in the gaseous form, which is of low temperature and low pressure. It enters inside the compressor, and in the compressor, it gets compressed to a gas of higher temperature. And so as far the refrigerants are concerned, they are of two major types. One is the natural refrigerant, which is nothing but some gas which we find in nature. And the gases that fall under this category are the gases which can be used as a refrigerant are ammonia, air, carbon dioxide, water, sulfur dioxide, and other hydrocarbons. But natural refrigerants are not normally used in vapor compression system because of their inherent disadvantages in terms of their low thermal conductivity or low latent heat or low specific heat capacity. For commercial purposes, mostly artificial refrigerants are chosen for use in the vapor compression systems. These refrigerants, basically these are all engineered gases. This means the gas is the refrigerant is a mix of so many other gases which have been selectively chosen to take advantage of their superior properties. The important properties that are required of a refrigerant are high specific heat capacity, high latent heat capacity, and a good thermal conductivity. And these gases are engineered or chosen or made in such a way that the final characteristics of these gases, these refrigerants, are very much desirable for use in a vapor compression system. And these refrigerants, they have some negative aspects as well. These gases, when they are left out in the open, they just go up, they ascend up, they uh, they just go up, and when they come in contact with ozone, they make a hole in the ozone layer. Ozone layer, as you know, is important um, to filter the harmful rays from the sun from entering inside the earth. So one of the adverse effect of these gases is if they are let out, if these gases are left in the open, they just go up, they make a hole in the ozone layer of the atmosphere. Normally this property is expressed as an index called as ozone depletion potential and also global warming potential. So basically this index is an indication of the damage this particular refrigerant can do to the atmosphere and the ozone layer. So the refrigeration engineers from time to time, they are inventing new types of gases which have low ozone depleting potential as well as less global warming potential. The refrigerant that is used in many of the existing systems, they use a gas called as R134A, and presently they are being replaced with another gas called as R600A, which has a very less global warming potential. So this picture shows how the temperature is maintained in a domestic refrigerator. Normally in a domestic refrigerator, there would be a freezer at the top, and the lower part of the refrigerator, lower part of the refrigeration system is called as the refrigerator. The evaporator or the evaporation coil will be located in the freezer section of the refrigeration system or the domestic refrigerator. The bottom part of the refrigerator will not have any cooling system. So the clinched type of evaporator or the cooling coil, they will be surrounding the internal space of the freezer of a refrigerator. At the rear of the freezer, there would be a small opening, and this opening will be controlled by a unit called as a damper. A damper is basically like a valve which allows the air to pass through, and you can regulate the amount of air that passes through this damper. And basically we could see a setting beneath the freezer or in the refrigerator section. You can see a small rotary knob with numbers on it. something like 1, 2, 3, 4, there will be a opening which will be in the form of a sector in this damper, and when the rotary knob is rotated, it either opens or closes the passage of cold air to the bottom part of the refrigerator. So we know that cold air would be denser, it will be heavier than the warmer air. So when this opening is open, the cold air inside the freezer will descend down by its weight, and it will come and occupy the part below the refrigerator. So the top part of the refrigerator is called as a freezer, wherein the temperature would be the least. So foods that have to be frozen or kept for a longer period of time, they have to be kept inside the freezer. So the commodities like meat, fish could be, or ice cream could be kept inside the freezer. And the portion just below the freezer is called as the chiller. So the freezer has the lowest temperature. Normally the temperature in this freezer could be adjusted between 0 to minus 25 degree centigrade, and the temperature in the chiller area would be between 0 to 4 degrees centigrade. And once when you come down, the temperature will be relatively higher than the chiller. Normally it will be between that will be somewhat greater than 4 degrees centigrade. At the bottom would be the vegetable tray wherein the vegetable can be stored. So this is yet another picture of a refrigerator wherein the freezer is at the bottom and the refrigerator is at the top. This is a version of refrigerator that is normally built in the United States, and they have made this refrigerator, this kind of an arrangement based on the principle of ergonomics. If you just see the foods that are being stored in these different compartments, in the case of a freezer, normally the commodities like meat and fish would be stored. So normally in a day, you'll be required to open this once. So it is enough you bend down and take these items from the refrigerator only once in a day. But wherein the commodities that are kept in the refrigerator system would be often used many times in a day, like beverages or other foodstuff which are stored at much lower temperature. And from the point of ergonomics, the most of the refrigerators that are built in US, they are arranged in this layout. The refrigerator will be at the top and the freezer will be at the bottom. And this graph shows the temperature distribution inside the refrigerator. So we can divide the zone inside the refrigerator into two different parts. One is the freezer part and another one is the refrigerator part. And if you see how the temperature varies inside the refrigerator, this uh, chart will be of help to visualize how the temperature varies inside the freezer and the refrigerator compartment of a refrigerator. The curve which is the top shows the temperature inside the refrigerator. As we could see, the variations in the curve are very minimal. You could see one or two lines overlapping each other. So the variation of temperature inside the refrigerator part is very minimal. The variation inside the freezer part would be more. Basically, a refrigerator um, could be regarded as an on-off type, which means when the refrigerator is running, the heat would be pumped out of the refrigerator. The temperature will decrease inside the refrigerator. And once when the desired temperature is reached, the supply to the compressor would be stopped. And when the compressor is stopped, there won't be any further cooling action. So the heat from the outside will start in coming inside or infiltrating inside the refrigerator. To reduce this heat infiltration, normally the walls of a refrigerator, they are insulated by means of some insulating material. Normally polyurethane foam is used as an insulating material. Earlier refrigerators, they used to be insulated with vacuum. There will be a double wall inside the refrigerator, and the gap between the walls would be evacuated so that the heat through conduction and convection would be reduced. So when the refrigerator is in operation, normally you set the temperature limit inside the refrigerator by means of a thermostat. A thermostat decides the range of temperature that the freezer needs to operate. So here in this case, a temperature limit of 10 degrees centigrade, 6 degrees centigrade has been set. So the cut-in temperature is set at -14 and the cutoff temperature is set at -20. What it means is when the temperature inside the freezer reaches -14 degrees centigrade, the compressor will be switched on by the thermostat. So this is called as a cut-in. The compressor would start working, the refrigeration system would start working, it would pump the heat outside. So when the heat is pumped outside, the temperature inside the refrigerator will go down. And once when the temperature reaches -20 degrees centigrade, the thermostat will cut off the supply to the compressor. And that's why this is called as a cutoff. So in the chart, we can see that this is the cutoff temperature and this is the cut-in temperature wherein the compressor will be switched on. So at this temperature, the compressor will be switched off. Now, when we start the fridge for the first time, initially the space inside the fridge will be at the ambient temperature. And when the system starts working, the temperature will gradually reduce. It reaches 0 degrees centigrade. It takes a certain time for the refrigerator to come down to 0 degrees centigrade. So a typical example is given here. So from the ambient temperature, which is 32 degrees centigrade, the refrigerator has taken 52 minutes to reach 0 degrees centigrade. And once when the temperature starts going below 0 degrees centigrade, it takes more time for the temperature reduction. So now when the temperature reaches the set limit, which is -20, the compressor stops. So the time taken for the refrigerator to reduce its temperature from the ambient temperature of 32 degrees centigrade to -20 degrees centigrade is 163 minutes, and this time is called as a pull down time. And once when the thermostat cuts off the supply to the compressor, there will be no further cooling. The outside temperature, the outside heat will start pouring inside, as a result of which the temperature inside the freezer gradually increases. And when it reaches -14 degrees centigrade, the thermostat will give supply to the compressor, and the compressor starts removing the heat from inside the freezer, as a result of which the temperature drops down. And this cycle continues. So we could find that once when the temperature reaches the desired limit, the compressor is switched off, and once when it reaches the upper temperature limit, the compressor is switched on, and hence a refrigerator is basically an on-off type of uh, refrigeration system or a heat pumping system. So this happens in a cycle. So we could see that the same kind of pattern will keep repeating itself. And this is what you'll be seeing inside the refrigerator. So with that, we come to the end of this session. Thank you for patiently listening.